What could be worse than ants in your sandwich? The most lethal predator on Earth flying over your picnic. That is, if you're a fly. But stay with me, because the story of dragonflies is absolutely insane, and it goes back farther than you can even imagine. If somebody asked you to find the most successful hunter on planet Earth, where would you look? Maybe you'd start by looking for lions in the African savanna, or tigers in the mangrove forests of India. Maybe you would travel to South America in search of the colossal harpy eagle, or go shark diving in the world's oceans. But in the end, you'd be wasting your time. To find the predator with the highest recorded success rate, there's no need to travel far. Hunting success is defined as the proportion of attacks made by an animal that result in success, or in other words, capture of prey. Lions only kill about 30% of the prey they go after, and harpy eagles are only marginally more successful. In contrast, African wild dogs are among the most successful predators on Earth, with a hunting success rate of about 80% when hunting together. But they still fall short of Earth's most successful predator, the dragonfly. With a nearly worldwide distribution and a hunting success rate pushing 95%, the dragonfly is the most effective predator known to science. Proof of the dragonfly's success can be found in Earth's ancient rocks, with fossil specimens dating back 300 million years. And in the humid swamps of the prehistoric past, some of them were gigantic. But what exactly makes dragonflies so lethal, and what do we know about their monstrous ancestors? Dragonflies belong to the order Odonata. They start their lives as nymphs, lurking in the depths of ponds, rivers, lakes, and wetlands. Here, they are voracious predators of the water realm, eating small fish, tadpoles, and invertebrates, but that could be its own video. Today, we're focusing on their glorious final form. As adults, dragonflies spend their time perching or in the air. They prey on small flying insects like mosquitoes and flies. And their flight is exceptional. They can fly in basically any direction. One reason for this is that unlike most insects, each of their 4 wings is controlled by separate flight muscles called direct flight muscles, giving them the ability to move each wing independently. This gives dragonflies precise control over their airborne trajectory. Another reason for their skilled flight is the wings themselves, which consist of veins and membranes that create a complex corrugated structure for high-performance flight. Additionally, on each wing, dragonflies have a pigmented spot called a pterostigma. This small section of the wing is heavier than the membrane in surrounding areas and helps increase their critical gliding speed by 10 to 25%. It does this by helping to prevent the wing from vibrating during gliding. Dragonflies detect their prey using their enormous compound eyes, which give them nearly 360-degree vision and the ability to detect even the slightest movements in their surroundings. Each compound eye is composed of over 20,000 light-sensing units called ommatidia, each of which have their own lens and photoreceptor cells. But what connects these advanced vision and flight systems together is the dragonfly's brain, which essentially acts as an advanced targeting system. It allows dragonflies to not just chase their prey, but actually predict the prey's flight path and intercept it. Dragonflies can basically lock on to a small insect in the sky and ignore all other visual information until they intercept the target. Scientists think that this combination of advanced flight, exceptional vision, and a brain evolved for interception is what makes dragonflies the most lethal predators on Earth. After all, we know that dragonflies are incredible hunters because they've been doing it for so long. That's because dragonflies are older than dinosaurs. A lot older, actually. The dragonfly body plan has been a winning strategy for 300 million years. Meganeura, an early dragonfly the size of a falcon. "300 million years ago, it was one of the first animals to ever take to the skies. Looking remarkably similar to their modern-day counterparts, Meganeura and others like it are known as griffinflies. Back then, in a time known as the Carboniferous period, Earth was covered in vast swamps and rainforests filled with prehistoric trees, mosses, and ferns. The sheer amount of plant growth during this time led to a higher concentration of oxygen in the atmosphere compared to today's levels. Scientists believe that this may have allowed griffinflies to absorb more oxygen through their respiratory system and reach larger sizes compared to the dragonflies of today. Another theory is that because literally nothing else had evolved flight yet, they had no aerial predators, which could have also contributed to their extreme proportions. While the dragonflies of today are not able to reach the size of griffinflies, they have remained remarkably similar to their ancient ancestors. Since dragonflies first took to the skies, Earth has undergone 3 mass extinctions, and our solar system has done a full orbit around the Milky Way. All this to say, the dragonflies gliding over your summer picnic are as effective at eating annoying mosquitoes as they are unfathomably ancient and spectacular. Thanks for tuning in to The Far Path.